before we continue learning integrals, I want to take a break and do these Riemann sums first, because Riemann sums, although we're not going to use them as much as integrals, they're a pretty good way to help us get into the groove of doing integrals and understand what exactly we're even doing when we're finding an integral, right? So say I have these graphs here, right, of y equals x squared. These aren't drawn to scale, but I did my best. And I want to find the areas underneath the curve, yet between the x-axis, right? So for our left graph, I want to find it from 0 to 3, right? So I want to find the entire right side of the graph right here. And on our right graph, I want to find the left side from -3 to 0, right? So I want to find these areas. Now this isn't something as simple as length times width, right? Or doing our 1/2 times base times height for a triangle, right? These are not standard shapes. So how can we find this area? It would be helpful, right, if we could do something simpler like a rectangle, just length times width, right? So what if I split this up into the area underneath this curve into 3 little rectangles, right? And I calculate the area of each rectangle, add them up, and say, okay, this isn't the exact area underneath the graph, but it's a good estimate, right? That's what we're going to do. And since we're doing right Riemann sums, the top right vertice of each rectangle is where we're going to have the graph, right? So I'm going to have 3 rectangles. So I'm going to start right here, right? This is my top right vertice, and I'm going to draw the rectangle from here. And it looks like that. And now we're going to go to x equals 2. This is the top right vertice of our next rectangle. And let me draw it. So we go down, across, and down. That's a rectangle. And then finally, our third subdivision, our third rectangle is going to hit the graph right here, where the graph should be. That's the top right vertice, and then we draw our rectangle from here. So we got 3 rectangles, right? And this could give us a pretty good estimate of the graph. You may notice, right, we have some areas of the rectangle that go above the graph. This means that we're going to end up with an overestimate of what the actual area is. So now that we've got these rectangles, we can just find their areas, add them all together, and say this is about the area underneath the curve, right? So we know the width of all of these rectangles. We know they're all equal to width 1. And we find their length by just finding what their y values are, right? So we can plug in each x value into our equation y equals x squared and solve for y, right? So we have our x value 1, right? At 1, y is going to be equal to 1 squared, so that's just 1. And then at 2, we write y of 1. And then y of 2 is going to be equal to, so y2 equals 2 squared, that's going to be equal to 4. And then at 3, y equals 3 squared, that's going to be equal to 9. So those are the heights of all our rectangles. Their width is all 1 unit long, right? So we're just going to do length times width. So for the first one, it would be 1 times 1. And then we're going to add the area of our second rectangle, which would be 1 times 4. Remember, width 1, length 4. And in our third rectangle, it's width 1 times the length 9. This becomes 1 plus 4 plus 9. And we get 1 plus 4 is 5, plus 9 is equal to 14. So that is about the rough area underneath the graph, about 14 square units. Now, let's do a right Riemann sum on our graph on the left, right? Let me choose a different color for this. We'll do green, right? And we're still doing right Riemann sums, so that means we want our 3 subdivisions, and the top right vertice of each rectangle is going to be where we hit the graph. So we're going to have one at -2, at the point -1, at the point 0. And when we draw our rectangles from -2, it's going to look like this. From -1, we'll have one that looks like this. And then from 0, it's literally just going to be a line. So this one, you may notice we have dead space underneath the graph, right? We have all this area that we're not covering this time, meaning we're going to get an underestimate, right? We know that all of our widths for the rectangles are width 1. Let's find their heights, right? So if we find the height at y0, or at x equals 0, right? Y equals 0 squared, we're going to get that that has height 0, and that's true because we just have a line. At x equals 1, or at -1, I should say, we're going to have that our height is equal to 1. And then at x equals -2, our height is going to be -2 squared. It's going to be 4. So we have the dimensions of all our rectangles. Now we just have to add up their areas, right? So for this rectangle right here, you see this big one? That's going to be equal to 4 times 1, height 4 with 1. So 4 times 1 And then our next rectangle, the dimensions are 1 by 1, so it's plus 1 times 1. And then our last rectangle, it's not even a rectangle, it's a line, has width 1 and height 0, so it's going to be 1 times 0. And when we add this all together, we get 4 plus 1 plus 0. And we get that our answer for our area is about 5 square units. Now you could see the difference, right? On our left example, we had an overestimate. On our right example, we had an underestimate, right? How does this help us understand the concept of integrals? Well, I'm not going to get to that just yet. That will be done in a future video. But one thing you should note with these right Riemann sums, right, is for our overestimate one, right, on the left side, for our overestimate, when we're doing a right Riemann sum, you notice that the slope of the graph is always increasing. And then when we got underestimates using a right Riemann sum, the slope was always decreasing. This is something important to remember for the next video where we'll look at left Riemann sums. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.